In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths papers 2.2 and 2.3. They're actually the same paper. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video as you need to. If you are looking for a different question from one of these papers or a different paper entirely, you should be able to find a playlist in the description below. If you can't, have a look around on my channel. Okay, let's get into the maths. In question 4, they give us two different equations and they draw their picture. I've just left it off. I want to make clear that it's two different images we're drawing out, or two different graphs. One looks like this and the other looks like that. And that means they cut off a certain area here. We're going to need that in part C, I believe. First thing they want us to do is this point here. It's P. Yeah, they've given us the x coordinates of this point, but they just want us to get it again. It's only one mark, so it's not a lot of work here. The point of intersection. It's just when these two equal each other. Oh, that's one thing I just wanted to point out. Which curve is which? You might not know, and you don't have to know. It will make a slight difference in part C. Your answer might come out as a minus if you get it wrong, but because you're getting the area, hopefully you would know to change it back to a positive. But we do know what E, the shape of E, looks like. It looks like this. Minus, when there's a minus up here, it goes back to this shape. 2x would just make it a bit higher, and 4x would make it just a little higher as well. This guy here is that shape. So I know this one is this guy, and sine would make it probably wave around as it goes down here, but that's part of a sine. Not important. Let's go on to part A. Put these two equal to each other. We get 4e to the minus 2x is equal 1 plus 0.5 sine 3x. They've given us the answer. It's, well, you can see it yourself probably, but it has two x's in it. This has two x's in it. They want you to get x equals. They want you to rearrange and get x equals. You have two choices. You could get this x on its own or this x on its own. Which is the correct one? Hopefully it's clear, because the answer they showed you has sine 3x still in it. So you don't want to mess with that. Leave it where it is. It's this one they want. The other clue is the answer they give you has a natural log. That natural log will appear when we're destroying this e here. So hopefully that's where you see that's where it all comes from. Okay, let's get rid of this 4 first of all. 1 divided by 4 is, I'd usually write 1 over 4, but their answer has 0.25 in it, so I'll leave it the way they do it. 0.5 divided by 4 is 0.125 sine 3x. We're already close to the answer they wanted. How do you get rid of e? Get natural log of both sides. Destroys that e, and a natural log appears this side. Again, it's now looking very much like what they gave us. And divide both sides by minus 2. I'll leave it down here. X is equal minus 0.5. So 1 divided by 2 would appear over here, which is 0.5. So that's a 5 of natural log. I hate writing out these long things. I also hate editing it, so I better just write it. Okay, that's the answer to part A. That's what they wanted you to find. It wasn't too hard, not too many steps. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. In part B, they want you to use the iterative formula from this equation here to find the answer, find out what the exact point of intersection is here. To give you more information, tell you like they want 6 significant figures on each step, and your final answer should be 4 significant figures. This question comes up every year, so you've no excuse not to be able to do one like this. They change slight things from time to time. like they haven't given you the iterative formula. You need to know to put a n plus 1 here and an n here. Or as some students put n and n minus 1. It's the same thing. It's fine. You need to know the steps to doing it. You need to make a first guess. They've given you the initial value, the first guess. I call it x0 or sometimes x1. Again, it's fine. 0.5, that's your first guess. How do you get the second guess? Well, if I've x0, I want x1. This will tell me x1 is equal if x0 is put in here. So I just put it all out, minus 0.5 times natural log of 0.25 plus 0.125. Where am I missing? Oh, am I missing a bracket anywhere? No. Sine times 3 times your previous guess, your x0 in this case. So 0.5. Put all that into a calculator, you'll get your answer. At this point, I like to tell you guys of a nice tip. This question only goes on 3 times, so you have to do this in your calculator 3 times. Not too bad. But sometimes the last question I did was 11 times. Really annoying. There's a nice little shortcut you can do if you learn to use your calculator a little bit. On your calculator, if you put in 0.5 equals, that's it. Your calculator now will remember that your previous answer was 0.5. Next, on your calculator, if you write this whole line out carefully, you need brackets, you need to be really careful. You need to do it all in one piece. But instead of 0.5 here, if you put in answer, it's a button on your calculator. What your calculator will do is it'll do this equation and put the previous answer in. And you get the answer. You haven't saved anything yet. But then if you press equals another time, it will do the same equation and put the last answer in, which will be this one. You'll get x2, x3, x4. You can get them all by just pressing one button. Anyway, let me just write out the answers you will get. If you put this one in, x1 would be 0.490832. That's 6 significant figures. One bit, a nice little cheat in the exam is if they ask for 6 and you're not good at rounding off, you're worried about making a mistake, just give 7 or 8. I think you get full marks. And hopefully you guys are able to round off. That's rounded off to 6 significant figures. I then underneath like to write out 4 significant figures. Because you know you get to the answer when your 4 significant figures repeats itself. Okay, again, you press equals in your calculator, you get the next number. If you want to do it the slow way, you just do all this again and put this 6-digit number in there. Or use the memory of your calculator, because our answers might get slightly different, I guess, if you don't use the memory of your calculator, because you're rounding off too much. Either way, what you should get is 0.491220, I think. I have a bit of a typo here, so that might be wrong. 4 significant figures there. These do not repeat yet, so that we're not at the final answer. x3 is 0.491201, which 4 significant figures is 4912. This does repeat. If you stay pressing equals, you stay doing this, you're not going to get closer in 4 digits at least. You'll get more exact in 6 digits. You get more exact in 8 digits, but 4 digits, you've done enough. This is your final answer for part B. Now that feels like it should be enough for question 4, but they do add on 4 more marks. So a pretty big question. They want you to find the area of this shaded region here. Hopefully that sparks bells in your head. The area of a region where a curve is integration. So what we want to do here is integrate. Integrate gets the area under a curve. So you could get the area under this one, and take it away. But again, hopefully you remember to get the area between 2 curves. We take the top curve. What was that again? That was 4e to the minus 2x. I've rubbed it out. The integral of the top curve, take away the bottom curve. So that was 1, so take away 1, take away 0.5 sine 3x. So the integral of this. And what we've learned from part B though is what units to put in, what limits, sorry. It's between 0, obviously. But where does it go up to? That's what we just found out. What was it? 0.4912. And you could use 6 digits to 7 digits, but they were obviously happy enough with 4 digits because their final answer, they want 2 significant figures. Let me put it in here. 0.4912. Okay, it's already quite a long question, so I will do these integrals quite fast. We're going to use substitution in them, but I'll do that in my head, as it were. So what I mean by that is the integral of this here, 4 is ignored, left alone. The integral of e to the power of anything is just e to the power of anything. We just leave it alone. That's how you integrate e. Unless what's up here is complicated. And it is quite complicated up here. It's not just x. So what we've done there is substituted it out. If you were to substitute minus 2x, you would end up differentiating it and get 1 over minus 2. And that would end up multiplying back in. So we can do all that in our head. Basically what it is, we integrate this as if it's simple. That's what I've done there. And then we divide by the derivative of up here. So we end up dividing by minus 2. If the derivative of the complicated thing has an x in it, it doesn't work. Because if you go through the substitution steps, it wouldn't work out. You'd end up having an x back in your integral. Okay, so hopefully that's clear. I think most students are happy. They've learned the shortcuts of doing these semi-difficult equations. So the integral of minus 1 is just minus x. The integral of this, the minus a half, we ignore that. It's a constant, comes outside. The integral of a sine is minus cosine. So minus cosine 3x. The minus will cancel that minus. We get a plus. Again, though, this was complicated. This 3x is not an x. It's more complicated than that. So we end up dividing by the derivative of this. So we divide by 3. And all of this is evaluated between 0.4912 and 0. So we just put it in. I'll write it all out. We get minus 2 e to the minus 2, 0.4912. Minus, we put, instead of this x, we put this number in, 0.4912. Plus, what's this? 1 over 2 divided by 3. So that's 1 over 6. Cosine 3 times 0.4912. That's just this guy put in. Then we take away minus, put in 0. That one's nice and easy though. We get minus 2 e to the power 0, which is just 1. So minus cancel, get a 2. Anyway, put 0 in here, we get minus 0. Again, just 0. And then we get minus 1 over 6 cosine 3 times 0, or well, just 0 we'll write in. That's just 1. Cosine of 0 is 1. So that becomes minus 6. Put all this in your calculator. Just be careful. Just do it all in your calculator. Just be really careful. The answer I got was, and I have checked it, it is correct, 0.609484. That's dead going on. And they wanted 2 significant figures. So that's 0.61. One of the most annoying things about questions like this is you don't know if you're right. If you make a slight mistake doing this, maybe you got 0.82. How you don't know that's right or wrong. It's very difficult. If you got a minus number here, you should know you're wrong. If you knew which curve went over the other, it can be difficult. All I'd say is just be really careful. Check your work. Hopefully you have 5 or 10 minutes at the end of your exam. Often students have 20 minutes. Some questions you do fast because you know. Some questions you can't do at all. So you save time everywhere in the exam. Hopefully you should have time to go back and check these questions. Just do them twice, 3 times. Anyway, that's it for question 4. If you have any follow-up questions, let me know in the comments. I'll do my best to get back to you. Thanks for watching and have a great day.